Okay, so we're going to walk you through how we go about doing a ground mount solar system. Different areas have different kind of circumstances and hurdles you need to think of. So we're going to kind of walk you through that. Typically, ground mount systems, they're going to be a little bit bigger. So a lot of times, say on this particular property, most people might be assuming you got to tie into your electrical panel that's either in your house or in your shop. Usually you're limited to 100 or 200 amp panels in these houses, where you might have to go back to the service on the property to be able to put in a larger solar system. You may ask again, why am I doing that? Simply put, a 100 amp panel is only going to have access to about 60 amps of power. A 200 amp panel is going to have access to about 80 amps of power, where if you go back to the 200 amp service and put in a 400 amp splitter box, you're now able to access 160 amps. So you can just put more power into it. So for this particular site, we ended up finding out that the service box was right about here, and the customer wanted to do their ground mount array, and it was going to be about 60 kilowatts roughly. And so when we're looking at where should we put it, we're going to take into account quite a few things. So over here, you can see we have quite a few trees. We have some younger trees here that, in this moment might only be 10 feet tall or 20 feet tall, but they are going to get significantly bigger over time. So we're not going to put any panels in this particular space. So what I'll do first is I'll draw out the array, and then we'll kind of model, can we do it in one single row ideally? And if we can't, then where can we do it in 2 rows with spacing in between so we don't have shadows? So yeah, let's draw this array real quick. And so we're going to choose our panels. So the most common panel that we use is a 550 watt panel. For ground mount systems in particular, we use bifacial panels, which we'll talk about and have talked about in other videos. But main reason being, 2-sided solar panel, you get backside gain from those panels for additional power production, which is a big advantage when it comes to ground mounts, because you get that reflective light and bounce back. So just a quick overview on that. The backside can produce an additional 5% power gain just from your standard grass background, a rock or sand-based background up to 10%, or a white painted background, 20 to 25% gain. And if you live in the northern climate like we do, snow is that extremely reflective, high producing energy. We do this ground mount system in this particular location. It's a fixed tilt system at 45 degrees. It kind of gets that balance between winter and summer tilts. Some people ask, why aren't you doing a tiltable racking? You would gain more with tiltable racking, anywhere from 10 to 15% more, but not everyone wants to go out and adjust their panels. Those tilted racking systems significantly more in cost. I would also add in significantly more susceptible to wind, especially when it's in that high position where the wind can hit the backside really hard. So if you don't have a good shelter belt and things like that, it can be a bit more of a risk. Whereas, if you're putting up 50 to 100 solar panels, adding 10% more panels might mean adding 5 or 10 more panels, and then you don't have to go out and tilt. So if you have the space, it just makes sense to add a couple more. So we're just going to draw on a quick array here. All our racking is going to be 2 panels high, and at the front of it, it's about 3 feet off the ground. The back and the very top of it, you're almost 14 feet in the air. So when we are designing these things, we want to let people know that it is a significant size system, and there is definitely some height to it. Yeah, so we're sitting at 30.8 kilowatts. I'm just going to drag this out to make it our full 60 kilowatts. I think our final system size was around there. And so yeah, we can now drag this array around the property, and the online measurements today are actually unbelievably accurate. Like, you're going to be within 1 to 2 feet for accuracy, and honestly, quite commonly, we've been within inches for the design. So knowing how big your system is important. So if we were going over by the shop, you no longer have a path here. There's other buildings currently in construction, so we're not going to put the array here. Going over in this area, we wouldn't do that strictly because you have all these trees that are coming up and going to be taller in the future. If they weren't there, yes, this might actually be a great location because you have that shelter belt on the back side. That's kind of nice. But just due to the fact that this array is a little bit too long, and with some future expansion for things, it's just not going to work. So what we're going to end up doing is taking this array and dividing it in two. And we're going to put it in a location that will fit. When you're going in two arrays and you're going front to back, we now have to worry about the shadows. As I said, at the back of the array, the very top of this thing, if you're looking at it, to this top angle is going to be about 14 feet from here to the ground, where this is going to be 3 feet. So there's going to be a bit of a shadow when the sun is hitting these, casting back this way. So we now have to take that into account with our spacing. I always like to go minimum 45 feet back from it, just to reduce the amount of shadow that might hit that back array. There still will be a bit of shading, which we'll show in the irradiance once we calculate that, to factor that in. So let's just quickly do this. 7.2, 52 panels, we'll change that to 26. We're going to duplicate that, put it over here. How do I space that out? Well, there's a ruler, might as well use that. Let's go on to 50 feet. And you want that to be front to back, not back to back. You want it 50 feet from the back of this array to the front of this array. So now we know we got good spacing on these panels. We're just going to have to do some quick inverter stringing. So with this system, we're going to have 4 inverters. Each inverter is going to be at least 11.4 kilowatts. Actually, I think we're going 6 inverters on this one. 11.4 doesn't quite math with that. Components, inverter. We're going to use 11.4 kilowatt crate. And we're going to have to manually string these. Strings are basically how many panels are going to be connected in each array. So with these inverters, you're going to be limited to a maximum size of 12 panels per string and a minimum size of 6 panels per string. So I'm just going to go and quickly string this out. All right, please note these are not the actual string sizes. We're just doing a quick stringing exercise so we can model simulation. We will actually do a system design to give real string lengths that are optimized for this array. All right, now we have those all stringed out. We're just going to do a quick simulation. Make sure that this is going to all make sense. And then you can kind of see the parameters of the ground mount array and what kind of losses you might get from things like shading. Okay, so this ground mount array is going to produce 1,242 kilowatt hours per 1,000 kilowatts. You're losing 0.1% due to tilt, which is almost nothing. 0.5% due to shading, and shading obviously due to that tilt angle. Sun, depending where it's in the sky, is going to hit the top of this panel, and it's going to be, carrying this way. At some points in the day when the sun's a little lower, more particularly in the winter months, you're going to get a further shadow angle, and it might catch the bottom of these panels. So you're not going to be as perfect on your irradiance in production there. Other things to keep in mind and look at. A little bit of soiling. You're always going to get a little dirt and dust on your panels. Snow, we factor in 3%. This is a pretty steep slope, so snow is not going to stay on your panels very long. And with it being a ground mount, one of the advantages compared to a roof, you are not going to be able to go on a roof and clean the snow off. On a ground mount system, you're going to be able to go on the ground, and lots of times if it's a dry snow, you can actually just tap on the panels and it'll vibrate off, or you can get a roof rake, wrap a towel around on it, and you can reach and pull it down without having to go, up there or do anything dangerous. And that'll help clear your panel snow off quite a bit quicker on a ground mount array. compared to one of the disadvantages of a roof mount array. You're not going to go on a roof, as it's too high and a little bit too dangerous for the rewards on that. Overall, DC to AC, there's a little bit of losses. Typically on our systems, we always factor in an additional 8% just as a simulations factor for safety. If you're doing a bifacial ground mount, I would typically just negate that. You're probably going to be able to go to 0% here, and that's still going to be a very safe projection. So in this particular system, by having bifacial panels, which actually don't cost any more, it's the most mainstream panel. A lot of people are like, well, how much more do those cost? Nothing. They're the same price. You would gain an additional 8,000 kilowatt hours over the course of a year. So you're about, yeah, it's pretty significant gains anyway. This is going to be your overall design layout, energy production over the course of a year. We always try and give the most safe projections, and I mean, let's just see how safe we are by going to this array, which we ended up installing for a customer. And so this is what the actual system looks like. This is the array. Some of the neat features with this system, he actually added in some batteries and some consumption CTs. So a lot of solar systems only show you how much energy you produce. So all you're ever seeing for numbers is your production. So you would literally only see this number. Here's what you've produced in the day from top to bottom. Once you add in that additional CT that goes on your loads, and you have the one on your solar, and basically you can see how much energy is going to the grid, how much is coming in. Super cool tool to be able to see that. So just to give you a quick walkthrough of that, in this current moment on this system, and this is a larger solar system, he's producing 27,000 watts or 27.19 kilowatts. That is going through his inverter, and that energy, 24.93 kilowatts, is going to the grid. We have a net metering program here, and so you're able to send that back and get credits used at a later date. He's using 2.26 kilowatts currently on his property, and he's already charged his batteries. So he has roughly 60 kilowatt hours of batteries, and he's already charged them. And so if you look at a full day graph, I just went back roughly one day here to show you what a whole outline looks like. So of his system and of his production, 21% of the energy went directly to his house, meaning as he produced it, it went right to his electrical loads, and he fed, his furnace, his stove, all the lights, everything on the property was being fed. 16% of it went to his batteries, and so he charged his batteries with 16%, and then the other 64% of his production went to the grid. And so it's all being consumed in the grid, which he's able to bank credits on. On the consumption side, which now we have more information on that as well, 34% of his consumption, so what he's using in a day, is directly from solar. So everything that he's producing, he's consuming 34%, and then from his batteries, consuming an additional 14%, and then the remaining consumption is from the grid, which is 52%. And so that's a lot of that from the grid he's going to be able to cover with the 64% that he sent back as credits. So pretty neat system, and you can kind of see it in real time how that energy is being used. So if we're starting from midnight, he's coming along, and you can kind of see he's not producing anything because the sun obviously isn't up at all. The sun starts to come up. This is in the middle of winter in December, so it's going to give you probably the worst kind of case scenario for your production. So at sunrise, his solar starts kicking in, and you can now see that he's consuming or producing 11 kilowatts. Of those 11 kilowatts, 0.02 kilowatts is going to the grid, 6.82 kilowatts going to his house, and 4.15 kilowatts charging his batteries to be able to prepare for the future. Of his consumption, he's not using any on his battery because he hasn't charged his battery yet. He's using 6.82 kilowatts from his solar and 1.16 kilowatts from the grid. As we kind of move along here, you can kind of see his productions change. He kind of hits a real high peak on the solar on the day here pretty early. Obviously, there's a bit of cloud here, otherwise you'd have a nice bell curve at the top. But yeah, you can kind of see how he charges his batteries. And now as we get a little bit later in the day and the sun starts to set, right about here, he starts to use that battery production that he charged his batteries with. So now he's starting to use those batteries. So of his production, his no longer using solar because the sun is down, and he's starting to consume from his batteries exactly 2 kilowatts and just a little bit from the grid. So he's just running pretty much all on battery power here. At peak, he's consuming 10.63 kilowatts just from his batteries. Very minimal from the grid, nothing from solar because there's no sun. He's not producing anything. And then as you can see, he starts to dwindle in what his battery life is. And now he's starting to consume again from the grid and still using a bit of the battery and just kind of going at that low cycle. And eventually, by the time morning kicks in, it starts the cycle all over again over here. So yeah, pretty neat on this end. You kind of get all the graphs, inverter power, how much energy it's using, state of charge, connected to your batteries, comparative energy. This is going to be his year-over-year power production. So the lighter kind of aqua color, we'll call that, turquoise, it's, you got your month-to-month power production, and then you got your comparative energy from where he was in, November of 2023 versus November of 2024. Yeah, a couple other cool things with this. You can see the layout. One of the reasons we really like the Solar Edge system, you can see in real time every single solar panel, what it's producing, what the energy production is, if there's any issues. If there was, a potential issue, say a panel stopped working or was broken or maybe an optimizer fails, this will turn black. And so then we know specifically that, something needs to be done. And by having that monitoring system, it gives you that peace of mind knowing every single panel is producing, whereas kind of the older string systems, the non-Solar Edge systems, you might have 10 panels all connected in a series. And if you do have to troubleshoot, you don't know which panel is causing the issue. Where this gives you, panel by panel monitoring, so you can see instantly where the issue might be. Yeah, awesome system. The other nice thing about the Solar Edge system tying into this, if you are working on it, panels, the advantage of the optimized system is when you turn the DC disconnect off, it's only going to allow 1 volt to come through the optimizer on each panel. So if you have 12 panels all tied together in a string, 12 panels times 1 volt, you're sitting at 12 volts. Whereas if you don't and you're just doing a straight string system, you're going 12 panels times 50 volts, you're closer to 600 volts. And so that's a very, I'll say less safe area and work environment where the optimizers kind of give you that peace of mind on that safety factor too. Yeah, if you have any other questions, and we appreciate you watching the video and learning how we design ground mount systems. If you could, please like and subscribe. It always helps us on our channel. And if you have any questions or you want to throw in some other information, we love hearing it in the comments. And yeah, looking forward to chatting with you in the comments.